Okay, and this problem says a child of mass 40 kg is in a roller coaster car that travels in a loop of radius 7 meters. So this is 7 meters. At point A, the speed of the car is 10 meters per second. So at this point, the car is going at 10 meters per second. Oops. Okay. At point B, the speed is 10.5 meters per second. Assume the child is not holding on and does not wear a seat belt. What is the force the car seat? What is the force of the car seat on the child at point A? Okay, so here's what we'll do. So the child is going in a circle. What kind of acceleration does the child have? The centripetal acceleration. Okay, so we'll calculate the centripetal acceleration of the child in each situation. Okay, now if it works out that for this speed, if the centripetal acceleration is smaller than g, okay, well, g, you can't avoid g. G is always going to be there. Okay, so here's what happens. The centripetal acceleration is your speed squared divided by r. If for given this, the radius of this track is 7 meters. If this number works out to be less than g, that is, your speed is such that this number works out to be less than g, then what nature has to do is r has to decrease, because this has to be a minimum of g. R decreasing meaning you're coming off the track. Okay, and of course if this is 0, then of course you know that you fall straight down. Okay. And then r becomes 0. Okay. All right, so let's calculate the centripetal acceleration of the child. Okay. We'll calculate the centripetal acceleration at point A, 10 meters per second square divided by 7 meters. And you can see that it's greater than g. 14.3 meters per second square. So since the centripetal acceleration is greater than what gravity can provide, what needs to happen? The track needs to push down on the child. Okay, and so well, this also ensures that the child will stay on the track. Okay, so the normal force plus the force of gravity. What is the force of the car seat on the child? So that's part A. Okay, so that's the force with which the car seat is pushing down on the child. Okay, and that is equal to okay, I'll write down the numbers, but then we'll do it in the mass of the child is 40 kgs. Centripetal acceleration is 14.3. And you can see that this is This minus that is 4.5, and we'll write that in terms of G. 4.5 divided by 9.8 is 0.46 mg. So on this ride, if you're going on this ride, oops, on this ride, oh well, I lost. Okay, on this ride, if you at the top, if you're going at 10 meters per second, the seat has to push you down with 46% your weight. Okay, and it doesn't matter who you are, you will stay on the track, and you actually don't need to wear a seat belt on that ride. Okay, so on most rides, you don't have to wear seat belts. That's how they're designed. Okay. They don't want you to freak out, but so that's why they make you wear seat belts and all that. And then, yeah. What is the force of the car seat on the child at point B? Okay, so point B, that's a little harder. So let's do that. There's point B. Oh, actually, so this is the center. So this is the centripetal force. There's mg. The car seat will have to apply a force in that direction. Okay, and what you need is so the force that the car applies plus the force of gravity should equal the centripetal force. Okay, so those two forces are providing you the centripetal force. Okay, and what are they asking? What is the force of the car seat on the child at point B? Oh wow, this is going to be a little messy, guys. Actually, what I'll do is so I'll have to be smart about the choice of my axis. So the y-axis is pointing along the center of the track, and so here's the x-axis, here's the y-axis. Okay, so that's how we got it. And I'll draw another copy here, x, y. Okay, so the force of gravity is mg cosine theta is the y component, mg sine theta is the x component. Okay, I'm going to do this problem. This part you're not responsible to study for the exam. It's just a little too hard, but it might be a good idea for you to review it. Okay, so I'll do this real quick and see if you can follow this. Okay. We don't know this angle, so we'll calculate that in a second. No, we don't know what. Oh. Yeah, but the car seat has to apply a force at an angle. We don't know what that angle is.
You don't know that it would be perpendicular to gravity?
No, it doesn't have to be perpendicular to gravity. Okay. And the centripetal force has only mv squared by r j. Okay, so the force that the car exerts, is centripetal force minus the force of gravity. Okay, well, we're just finding the components. Okay, so this is mv squared by r j minus, here's the force of gravity. Okay. It's got a negative x component because our x-axis was drawn in this direction, and this force has a negative x component. Okay. And plus mv square r minus mg sine theta j. Okay. So this is equal to minus mg cosine 30 I plus mv square r minus mg sine 30 j. I'll write down the numbers, but you guys, well, I'll write down the numbers. M is 40 kgs, G is 9.8, V at B is 10.5 meters per second. And R, the radius of the track, is still 7 meters. Okay. So if you put those numbers in there, you can get the force that the car exerts, the car seat exerts. Okay. And what else is the problem asking? What minimum speed is required to keep the child in his seat at point A? So here's the deal. Okay, so when the centripetal acceleration is equal to g, that's the minimum speed. Okay, so for this track, whose radius is 7 meters, okay, the minimum speed is 8.3 meters per second. Okay, so if you're designing this roller coaster ride, what you want to make sure is at that point you're going at least at 8.3 meters per second. So you're dropping people from a hill so that you're going fast enough. Okay, you're of course making sure that they're going at 15 meters per second. There's no way they're going to come off the track. Okay, and so on. So that's the design element. Okay, let me. What is the problem number on that?
Century.
I'm sorry?